In 2022, two separate incidents were reported in which milk adulterated with sanitizer was distributed to consumers. In both cases, the affected milk was delivered to schools, leading to children being admitted to the hospital, resulting in broad media coverage and a host of bad publicity for the dairy industry. These types of events are a serious risk for the dairy industry, as they degrade overall consumer confidence in dairy products. And while New York milk processors were not involved in these incidents, our goal in the Milk Quality Improvement Program at Cornell was to provide the New York dairy industry with practical guidance to prevent these types of events from occurring in the future. Our approach was to conduct an applied research study to identify and evaluate factors at the processing facility level that could lead to unintentional contamination of milk with sanitizers, as well as evaluate and identify suitable methods for the detection of sanitizer in fluid milk. To get a picture of current industry practices, we surveyed milk processors of all sizes across New York State about their use of sanitizers and what practices they currently employ to prevent sanitizer contamination in milk. 75% of the surveyed plants reported using a peroxyacetic acid-based sanitizer, and the remaining 25% of the plants used a chlorine compound-based sanitizer. The participating dairy processors reported utilizing multiple methods to prevent and detect sanitizer adulteration. The average dairy plant in our survey used 4 different methods to evaluate their pasteurized milk. The most frequently reported practice was the visual inspection of the equipment by the operator to determine if residual sanitizer was present before milk is processed. The second most reported was tasting and/or smelling the product to detect the presence of residual sanitizer. Our next goal was to develop methods and best practices for detecting peroxyacetic acid or chlorine in milk through sensory training and by using chemical detection methods. First, we determined the lowest amount of sanitizer in milk that could be detected by consumers through smell, then exposed a group of consumers to training on detection of sanitizers in milk. Our results show that there was a large difference in the lowest amount of sanitizer that each individual could detect, and overall, we saw no improvement in an individual's ability to detect sanitizer contamination, even after training. However, in follow-up sensory experiments, we focused on developing screening procedures to identify individuals with a naturally high sensitivity to sanitizers, a promising approach to improving detection in processing facilities. We then tested commercially available test strips and kits that are used to determine concentration of sanitizer in water on different concentrations of chlorine-based and peroxyacetic acid-based sanitizers in milk. While none of the test strips or kits designed to detect chlorine-based sanitizers yielded promising results, peroxyacetic acid-based sanitizers, the most common type of sanitizer used in New York dairy processing facilities, were detected, even at the lowest concentration tested. These test strips are inexpensive, easy to use, and provide processors with a rapid detection method for preventing sanitizer contamination in milk. Overall, our study provides practical guidance to the New York dairy industry to protect our consumers from unintentional sanitizer contamination and to ensure that they feel confident in continuing to purchase and consume New York dairy products.